Good morning, all.
Good morning, sir.
Morning, sir.
Good morning, sir.
Good morning, sir.
So, tell me any general problems in chapter 5? Any major problem you are facing?
Yes, sir.
Do you have any queries or any doubts regarding chapter 5?
सर एक एनालिटिकल क्या था ना सर, एक बार एक्सप्लेन कर देंगे शॉर्ट में?
Analytic.
यस सर.
Okay, any other?
नो सर.
Okay, I will explain. And what about others? Tell me, so today, if you have more problems, then I can discuss because I don't want to start the new chapter today. Already half an hour over.
Good morning, sir.
Morning, morning. Am I audible clearly?
Yes,
Yes,
sir.
sir.
You are clearly audible, sir.
Okay. Are you practicing or not? Chapter 5 problems.
सर पढ़ना शुरू किया है.
कर रहे हैं।
जल्दी करो अदर बिकॉज मतलब मिड सेम एग्जाम ज्यादा दूर नहीं है। अच्छा एक चीज बताओ तुम लोग अभी क्या क्या मतलब प्रैक्टिकल्स एंड थ्योरी पेपर मतलब अटेंड कर रहे हो।
तो
व्हाट आर दे।
अभी तो फिजिक्स का सर आज ही भेज दिए हैं और बीई का लिख रहे हैं, फिर उसके बाद बीएमएस का रिपोर्ट राइटिंग है, ये सब चल रहा है।
सर फिर फिजिक्स का भी सर 40 क्वेश्चन
सर
दिया है।
एईसी का सर 2 प्रैक्टिकल
हाँ,
अटेंड कर
बीई का भी 15 क्वेश्चन और दिया है।
यस सर।
और फिजिक्स का भी प्रैक्टिस क्वेश्चन मिला है 30।
सर 40।
तो एक्चुअली सिलेबस में सिलेबस मतलब ओवरऑल तुम्हारे कोर्स में कितना सब्जेक्ट है वो मैं पूछना चाह रहा था।
सर
10
9,
सब्जेक्ट 9
10 है,
9
9 है
9
क्योंकि
9
योगा
10
तक ऐड नहीं हुआ।
9 कैसे।
सर क्योंकि सर 10
एक तो सर
प्रैक्टिकल
हमारा,
एंड थ्योरी मिला के सर।
हाँ सर,
नहीं देखो एक तो गया मैथमेटिक्स
हाँ
उसके
यस
बाद
सर।
फिजिक्स।
हाँ
सर फिजिक्स के 2 सर,
सर फिजिक्स हुए
लैब
2
एंड,
और
हाँ फिजिक्स
एईसी हुआ।
लैब एंड थ्योरी।
नहीं
हाँ
सर सर
सर,
बीएमएस।
एनालॉग इलेक्ट्रॉनिक सर्किट हुआ सर, एक एक हुआ बेसिक
एईसी का 2
मैन्युफैक्चर।
ना, एईसी का 2।
बीईई बी डबल
हाँ
ई ना।
हाँ,
यस
बी
सर,
डबल ई
बी
हुआ।
डबल का 2।
सो बी
और
डबल ई थ्योरी एंड प्रैक्टिकल।
हाँ
यस
सर,
सर। सर देन
और
ईवीएस है सर, बीएमएस है।
बीएमएस
ईबीएस
है
बीएमएस।
हाँ
और योगा भी है।
सर, योगा को मिला नहीं सर, 10 होता है लेकिन सर अब तक हमारा योगा का नहीं आया तो 9 होगा।
अच्छा और एनी फर्स्ट ईयर मींस sorry first semester labs are you are attending।
सर
केमिस्ट्री,
फर्स्ट सेमेस्टर लैब में सर
ई
केमिस्ट्री था
ग्राफिक,
सर, ई ग्राफिक्स का था और एक पीकॉम का था सर, मतलब उसका
हाँ
लैंग्वेज लैब।
वो मतलब करवाया जा रहा है अभी या।
नो सर, वो सर
नहीं सर,
फर्स्ट
नो
सेमेस्टर
सर,
वो
वो
सब
सब
खत्म हो गया
नहीं
ना
है।
सर। फर्स्ट
नहीं तुम
सेमेस्टर
लोग फर्स्ट सेमेस्टर तो ऑनलाइन में किए हो ना तो ऑफलाइन में वो सब अच्छा तुम लोग तो ऑनलाइन।
ऑनलाइन ही है सर हम।
ये सर हम
ओके
लोग ऑनलाइन है सर।
माय मिस्टेक मतलब मैं
सर
सोच रहा था ये ऑफलाइन वाला सेक्शन है तो।
सर ऑफलाइन वाले भी कोई अटेंड नहीं कर रहे हैं सर, सेकंड सेमेस्टर वाले ही सिर्फ अटेंड कर रहे
अच्छा ओनली सेकंड सेमेस्टर ही
हैं।
हो
यस
रहा
सर।
है।
ये सर।
नहीं नहीं जैसे सीनियर्स का कुछ हो रहा है ऐसे तुम्हारे।
सर वो लोग का
अ,
जैसे डीएसए वैसे था ना सर, इसीलिए वो लोग का हो रहा है।
हाँ मतलब प्रीवियस सेमेस्टर में जो था लैब जो अटेंड नहीं कर
हाँ
पाए थे ड्यू टू
ये
ऑनलाइन
सर।
तो वो करवाया जा रहा है। ठीक है तुम लोग को अभी अभी तक इम्पोर्टेंट मतलब अपना कंप्यूटर साइंस का कुछ लैब छूटा नहीं होगा। और
नहीं
कंप्यूटर
सर।
साइंस का वैसे तो मतलब ऑनलाइन में भी सब हो सकता है। जैसे मतलब फिजिक्स प्रैक्टिकल केमिस्ट्री प्रैक्टिकल देन ये बीई प्रैक्टिकल्स ये सब मतलब ऑनलाइन में थोड़ा मुश्किल है करना। इसके लिए ऑफलाइन ही करना पड़ता है।
ये
और
सर।
मैक्सिमम मतलब वो मैकेनिकल का जो लैब होता है वो सब तो हाथ में ही करना पड़ता है तो इसीलिए जो मतलब ऑनलाइन में जब थे उस टाइम का जो प्रैक्टिकल्स था वो अभी कर रहे हैं बहुत सीनियर्स। ठीक है तो हाँ someone asking me about analytic function कौन पूछ रहा था।
समी।
ओके
सर एनालिटिकल एंड सिंगुलर, ये तो।
एनालिटिक एंड सिंगुलर पॉइंट्स।
यस, बस बस ये सर थोड़ा सा मतलब शॉर्ट में एक्सप्लेन करते हैं।
ठीक है Okay, so analytic means a function is called analytic. Okay, analytic means a function may be analytic or may not be analytic. Now, when a function is called analytic, so we can define it in many ways actually. Fx is called analytic at some point. Okay, at x is equal to x naught. If, can you tell me anyone? Power series representation. Power series representation exist about the point x is equal to x naught. That means if we can write fx is equal to summation am x minus x naught to the power m form. If we can write this, then fx is called analytic at x equal to x naught. Okay, and the technique to write fx in the power of x minus x naught. What is that? How to write power series of a function about a point. I told how to represent it by using a Taylor series representation, right? Taylor series formula. So what is the Taylor series formula? F x naught plus x minus x naught into f dash x naught plus x minus x naught by factorial, sorry, x minus x naught whole square by factorial to f double dash x naught and so on. So that is the main thing. If the function fx can be represented as a power series in the power of x minus x naught, then it is called analytic at the point x is equal to x naught. Okay,
Yes, yes, sir.
and the other definition is that means that you can say as a result, as a corollary, means you just check the differentiability of the function. Okay, or you can write if fx is defined and infinite times differentiable, at x is equal to x naught, then fx is called analytic. Actually, I have used the second notion of this analytic. Okay, this second notion, second form means you check at the point x is equal to x naught fx is defined or not. If defined and if it is infinite times differentiable at the point x is equal to x naught, then fx is analytic. We have used the second definition, right? We have not checked whether we can write the power series or not.
Yes, sir.
So how to check? Again, I am giving some example like fx is equal to x divided by x minus 1. Now, if I ask at x is equal to 1, so here x naught is our 1. At x is equal to 1, is it analytic? If x is undefined, at x is equal to 1, fx is undefined. So what we conclude? Look, to be analytic at the point, fx should be defined and it is infinite time differentiable. So the first criteria, it is violating. fx is not defined at that point, right? So at x is equal to 1, since fx is undefined, therefore what? fx is not analytic at x is equal to 1. You got it?
Yes, sir.
Now you can check about the other points also. Here I am asking only for x is equal to 1. You can also check for the other points. Like x is equal to say 2. Now at x is equal to 2, fx, is it defined?
Yes,
Defined
sir.
is it final means finite value. So if you put x is equal to 2 in fx, the value is means finite, na? So it is defined. At x is equal to 2, fx is defined. And the other criteria, what is that? Infinite times differentiable. So you think, can you differentiate fx infinite times at the point x is equal to 1? Means you differentiate it one by one time and then put x equal to 1. If they are defined, then you can conclude that fx the means fx is infinite times differentiable at x is equal to 1. So for that means we cannot verify for infinite times, right? We cannot verify for infinite times. So for that, at least you can check means f dash x, f double dash x. Are they valid or are they defined at the point x equal to 2? At x equal to 2, are they valid? You can check it. They are valid. They are finite. Okay. So we can means write that means we can, if we can differentiate it up to infinite times, all the differentiations are valid at x equal to 2. Therefore, x is equal to, at x equal to 2, fx is analytic. Okay. Do you get it why that is analytic?
Yes, sir.
Similarly, except x is equal to 1, if you take any other point, at that point, the function is analytic. Okay. Any doubts still?
No, sir.
Now come to the singular point, regular point. Okay. Now these terms are related to a differential equation. These terms are related to a differential equation. Singular points, regular points, regular singular points of a differential equation. So for that, I am assuming a second order ODE. This. Okay. Now, when a point x is equal to x naught is called regular point. Okay. Here we are means characterizing the point. Previously we were characterizing the function. Okay. So here we are classifying the points. So x is equal to x naught, that point, it is called regular. When? Do you remember? If px and qx are analytic at x is equal to x naught. Means to be a regular point, you have to verify this px and qx are analytic at x equal to x naught or not. Okay. The previous definition for Px also you verify in that way. For Qx also you verify in that way. Are you getting or not?
Yes sir.
well still मतलब फिर भी कहीं से लग रहा है कि ये क्लियर नहीं है, बताओ.
No sir.
And when it is called a singular point means otherwise case. Otherwise case it is called singular points. So what is the otherwise case?
Sir, non-analytical.
If Px or Qx are not analytic, right? मीन्स ये दोनों में से अगर कोई भी एक एनालिटिक नहीं होगा तो दैट पॉइंट इज कॉल्ड सिंगुलर पॉइंट. And for regular singular point, do you remember? For regular singular point, we will not verify Px and Qx. Instead, we will verify what? X minus x naught into Px and x minus x naught whole square into Qx. If these two are analytic. This. So I have already given so many examples regarding regular point, singular point, regular singular point. So now I'm means for exam point of view, I'm telling you what type of problem you have to practice more. Uh, so in 5.1, first of all, you have to remember this type of familiar series. I told so many times. You have to remember some familiar power series um, along with their closed form. Okay. Now, so power series solution, that is a case that may come in exam. Find the power series solution uh, in the power of x. Okay. So find power series solution. If it is asking only, then don't apply Frobenius method. Okay. If they are asking find power series solution only, so if you apply y is equal to summation a to the power n, not x to the power r, a x to the power n. Okay. Now radius of, you may get some question on radius of convergence, maybe MCQ type also, because these are short type. Answer is very small. Only you should know these two formula, and by using these two formula, it may be asked what is the radius of convergence for this series. Okay. And you should know the existence and uniqueness criteria for power series solution that I told. That is theorem 3 point, theorem 1. Okay, now coming to that exercise problems. So practice problem number 2 to 5. Okay, and 6 to 9 also. 6 to 9, these are fast order mostly, and 10 to 12 you practice 2 3 problems from here, and 16 to 19 these are initial value problem, only the difference is but you have to find the value of arbitrary constant at last. So you may get a problem from this power series solution, means 6 to 19. Okay, in between 6 to 19 you may get a problem, not exactly from the exercise, means from of this type. Now Legendre's equation. So Legendre's equation actually the solution process, it is not that much important. The important part is that expression of that Pnx in summation form. Okay, this one, and then you should remember at least P naught, P1, P2, P3. Fine. Legendary polynomial up to degree 3. Next, from problem set 5.2, you can practice the problems which I have already marked. Right, I have marked na during the uh, topic.
Yes, sir.
I have marked, so you practice those type of problems. Actually, there are only derivation type of problems. No numeric type of problems are there. Derivation like Rodrigues formula, Punnett recursion, uh, then reduction to Legendre's equation, then Pn1, Pn minus 1, this type. Okay, generating function. Now in 5.3, so it is also important from exam point of view. You may or may not get a question from 5.1, but definitely there should be a problem from 5.3, Frobenius method. Okay, so you should practice Frobenius method, and always means mostly you focus on the first solution, means y1. And of course, sometimes you have to see the second solution also whenever the first solution is known in terms of closed form. Means whenever first solution appears in the closed form, in that case, second solution may be asked. So there are 3 cases I told. Whenever the roots are not differing by integer, that is the simplest case. For both the roots, you will get the solutions y1 and y2 in similar manner. But whenever it is a double root or roots are differing by an integer, means whenever it is a case 2 or case 3, in that case, second solution finding, it is not that much easier. You have to apply reduction of order, as I told. Finding first solution, it is easier, but finding second solution, you have to apply reduction of order. And always, whenever you are solving by Frobenius method, after solving the initial equation, you find the first solution for which root? I told, for the larger root, right? Means r is equal to I am getting 3 comma minus 1. So y1 will be derived for what? For which root?
The 3.
3. So that always you maintain, and rest is a practice. You have to practice some problems from the exercise. First of all, you see the examples of this chapter, how they have solved, and then you can see my Jamboard work also. The Jamboard I have solved several problems. Also in my handwritten note there are some problems, and you have to solve some new problems apart from that. 2 to 13. Okay, 2 to 13. And Bessel's equation, that is a means recent topic, so you may remember what I told. Here also you have to remember the expression for J new. Okay, J new, and then whenever new is an integer, what is the formula, and what is the relation between J of minus n with Jn. Then that J half J minus of proof. There are so many derivations like that legendaries. Okay, so there are so many derivations. You have to practice those derivations, these four properties, ABCD. Actually, I have done everything. I have shown everything in the class which are important. तुम लोग को भी प्रैक्टिस करना पड़ेगा, नहीं तो याद नहीं रहेगा. ये गामा बीटा फंक्शन का थोड़ा बहुत प्रॉपर्टीज याद रखना है, बिकॉज वो एग्जाम में आ सकता है शॉर्ट क्वेश्चन में, बीटा गामा का वैल्यूज. ओके, एंड यहाँ पे देखो 2 to 10 में देयर आर सम ODs which are initially not in Bessel's form, but you can reduce it to Bessel's form by taking some substitution, and those substitution are given in along with the problem, right? So you take the substitution and you reduce the equations into Bessel's equation, and then you find the general solution. And here there is a trick to write the general solution. Not always we can write a general solution for Bessel's ODE, right? So there have a case integer not integer case. Do you remember whenever n is integer, we cannot write, means sorry, new. Whenever new is integer, we cannot write the general solution. But whenever it is a fraction, it is not an integer. In that case, we can write the general solution. हाँ बोलो, कुछ बोल रहे हो. एंड यहाँ पे देखो, और इन वो डिफरेंशिएशन एंड इंटीग्रेशन रिलेटेड भी कुछ वो डेरिवेशंस है, और दैट बेसेल्स इक्वेशन रिलेटेड, that you have to practice also. And 5.5, it is not in your syllabus. I hope all of you have understood what you have to do, right? I have given the summary of chapter 5. So you start practicing, start problem solving. If you are stuck anywhere, you can WhatsApp me. If time permits, I will see and I will respond.
Yes, sir.
सर 5.4 से कौन कौन से क्वेश्चन करना है?
5.4 से I mark from 2 to 10. Not all the problems you have to solve. Only those which are related to one step substitution from 2 to 10. Okay. From 2 to 10, I told na, problem number 2, 3, 4, 5, then 7, 8, 9. These are one step substitution. So you can try these problems. Some of them are already solved. So these problems, and here you see problem number 19. Okay, then 23, 24, 25. These are the exercise problems, and apart from it, there are so many derivations in the theory portion also. Like j minus n is equal to minus 1 to the power n into jn. This property proof. Okay, then that gamma half proof. Then j half and j minus half proof. Then proof of these four properties. Okay, so these are also important. So do you get it? देखो मैं बार बार बोल रहा हूँ कि मतलब प्रैक्टिस करो, नहीं तो एग्जाम में लिख नहीं पाओगे डेफिनेटली. मतलब फॉर पावर सीरीज सॉल्यूशन यू कैन राइट सम लाइन, यू कैन राइट द मींस ओडी, यू कैन राइट द y is equal to x to the power r summation m x to the power m. You can write the derivatives also. uh, you can substitute it. मतलब up to that everyone can do, but after that the simplifications and the addition of those summations and then comparing the coefficients, यहाँ पे calculation mistakes बहुत होता है. प्लस माइनस में भी मिस्टेक हो जाएगा तो रिकरेंस रिलेशन चेंज हो जाएगा, इंडिशियल इक्वेशन चेंज हो जाएगा, फिर ओवरऑल सॉल्यूशन गलत हो जाएगा. ठीक है, तो अच्छे से प्रैक्टिस करना है.
सर मिड सेम का पोर्शन है.
मिड सेम का पोर्शन इट इज नॉट डिक्लेयर्ड येट, बट मींस आई केम टू नो दैट इट इज अप टू 6.2. चैप्टर 5 एंड चैप्टर 6 का 6.1 एंड 6.2. ओके
ओके सर.
तुम्हारे मतलब सिलेबस आगे ही चल रहा है, कोई इशू नहीं है. सिलेबस कंप्लीट नहीं हुआ है ऐसा नहीं होगा. ऑफलाइन का थोड़ा दिक्कत हो सकता है, वो थोड़ा पीछे चल रहा है. Okay, that's all for today. So from the next class, we will start that Laplace transformation. Okay.
Yes, sir.
I will give all present.
Thank you, sir. Thank you, sir.
Thank you, sir.
थैंक यू सर.